It has become a public secret that the Republic of Indonesia is the largest palm oil producer in the world. Approximately 60% of palm oil in the world is produced in Indonesia. Some products like crude palm oil, crude kernel oil, shell powder, and anything derived from these products have been delivered anywhere in the world. But during the production process, some waste is also being produced unavoidably. One among those wastes is an empty fruit bunch, or EFB. The number of EFBs is huge, as it is 23% part of the initial fully fresh fruit bunch, shortened as FFB. 45 tons of FFB are being processed every hour in one palm oil factory, or 900 tons per day approximately. This means 207 tons of FFBs are produced daily in one factory. There are 2,800 palm oil factories in Indonesia, which means there will be 207 tons multiplied by 2,800 factories, which means around 579,600 tons of EFB is being produced daily. It is a huge problem, but it is also a huge opportunity. Let's think of a small number of EFBs produced by one factory, which is 207 tons a day. We can turn this into 41 tons of lignin, 81 tons of bioethanol, 40 tons of CMC, and 40 tons of fertilizer. As you might already know, up to date the EFB is only used for mulch, fertilizer, or occasionally used as a burning material, wood pellets which are low in value, or turned into fertilizer but not efficiently, because too much effort is needed to make this product. There are two types of known wastes from palm oil production. 1. EFB stands for empty fruit bunch. 2. POME stands for palm oil mill effluent. It is fluid waste that can be processed into methane gases to be used for electric power plant fuel alternative. But today let's set our focus on EFBs. Up to date, EFBs are only processed into the following products. 1. Palm acid oil or PAO extract. Extracted using shredder and bunch press. But this kind of process also leaves behind an environmental problem. 2. EFBs are burned into ash used for fertilizer, but also give us aerial pollution. 3. Used as a mulch, but doing so is estimated to damage the soil. And even the cost is also considered high. 4. Turn into fertilizer by using anaerobic fermentation. But the time requirement is rather stringent. The time needed for the fermentation is more than 100 days. As a result, the area needed is also extremely wide, because the wastes keep coming while the fermentation has to wait for 100 days. 5. Turned into a wood pellet. But to do this, a lot of energy is needed, and the initial investment is considered high, while the value is minimal.
There are still 3 more ways to utilize the EFBs using advanced methods. 1. Make lignin from this and also its derived products, such as benzena, toluene, and xylene. 2. Turn this into bioethanol. 3. make better fertilizer out of bioethanol production wastes. Here, we are talking about bioethanol stillage waste, although the three methods above are considered better compared to previous methods. But efficiency is still a hurdle. That's why Agrotechnology wants to make an optimization regarding those three methods above by using the following ways. 1. Using Hitachi High Technology Learning Engine to reduce the research expenses while shortening the research process at the same time. 2. Using enzyme and yeast created by Professor Wen-Chien Li Ph.D. It can shorten the fermentation time requirement from 7 days long to 24 hours. Using this, the space needed is reduced significantly, and the cost is also reduced at the same time. 3. Optimized delignification. Up to date. Delignification is using higher concentration NaOH with a steam explosion. The requirement to do this is rather high. A lot of energy is needs a long time, leaving a non-environmentally friendly waste. To avoid these problems above, we will be using ultrasonic waves added with microwave and DES. Stands for deep eutectic solvent, as a replacement for NaOH. Let's study the feasibility business for this EFB. Let me give you the big picture first before we dive into the detail later. This way, you will see the conclusion sooner. Before decide to see the detail, there are two types of EFB, which is dry type and wet type. In the business viewpoint, the difference is negligible and insignificant. It is only on preparation machines. We need 525 million rupiah on dry type. On the other hand, wet type need 875 million rupiah. The gap is only 350 million rupiah compared to the overall capital. This number is insignificant. So, let's focus on dry type of EFB. This is the initial investment. We put it to the right side now, so we can use it later. This is operation expenses monthly. This is monthly income. This is the benefit.
This is tabular data for our investment in machines. Basically, we have 4 lanes here. The preparation lane will produce palm acid oil. The treatment lane is where delignification is going to happen. The bioethanol lane will, of course, produce ethanol, and the fertilizer lane will produce fertilizer. This is the list of the machines we need for each lane respectively. Here is the quantity of each machine, and here is the unit price. Now, let's take a look at the total price of each machine. To get this value, we do a multiplication between the unit price and the quantity. Here, if we look at the formula editor, you will see that the unit price is being multiplied by the quantity. Now, we are going to summarize this column to find the total value. Look at this cell. This formula is copying the entire value in this column, which means it is summarizing the entire column values. Now, this value is the number of investments needed for our factory. Now, we are looking at the investment on utilities. This is the machines needed in the utility lane, the power needed, and the quantity of each machine. This is the unit price. And again, total price is the multiplication between the unit price against the quantity. If we summarize the total prices of each machine, then we got this. The sum of investment needed for the utility lane. Now, let's talk about the investment in the control room. We have 5 items here: HMI, monitor, control panel, Ethernet configuration, DCS. These items usually are sold in a package. So, we have this number for the investment in the control room. Here is the data about the investment on the factory building. We will waste too much time to discuss this, so we will go straight to the conclusion. The number is this. Now is the time to find the total value of the initial investment. It is easy. It is equal to the investment on the factory building, added with the investment in the control room, added with the investment on the utility room, and added with the investment on engines. And the number is this. Let's take a look at the monthly operational expenses. At first glance, it is easy to understand, but in fact, every number in this data is deeper than it may looks. All right, let's start with raw material data. Take a look at the raw material table here. We have a single raw material here, which is EFB. We will make our products out of it. On the quantity table, the quantity is 6,000 kilograms, which is 6 tons. The price is 70 rupiah, and the days is 25. If we multiply all of them, the number will be like this. Next is additive materials, where this number comes from. We need 5 kinds of additive materials, which is DES, deep eutectic solvent, cellulose enzyme, yeast, microba digester, and phosphate. Take a look at the DES's quantity, which is 216, where this number come to be. Take a look at the formula editor. As we discussed before, the raw material is 6,000 kilograms of EFB, so the number 6,000 represents this. Then 3.6. Every kilograms of EFB will need 3.6 kilograms of DES. But after the process, the DES recovery exceeds 99%. Some experts said that it is 100% recovery rate, but we stick to 99%. As we believe that a certain lose might happen whether it is in the production process or in the recovery process. So the lost DES will be 1%. In this process, we produce 20% lignins. Next is cellulose enzymes quantity. Again, 6,000 is the number of raw material. 80% is the leftover material from the process before, which is delignification. To make bioethanols, we need cellulosa enzyme and yeast. The value needed is the same, which is 1% from the present material, which is 48 kilograms. Now, take a look at the microba digester. After delignification and bioethanol process, the raw material is now reduced by 40%, which is now 60% left. To make fertilizer out of this, we need 0.1% of microbidigester and 5% of phosphate, which is 3.6 kilograms and 180 kilograms respectively. Maintenance. Maintenance cost is more like constanta, so explanation about this is not necessary. Next is energy. We don't use existing power plant to power up our engines. Rather, we use our own turbine to produce electricity by using existing palm oil shell as our fuel. All right, let's dive into our data. We need 150 kilowatt hour to operate our engines and anything related to electricity, and will be operated 20 hours a day and 25 days a month. So the need will be 150 multiplied by 20 multiplied by 25, which is 75,000 kilowatt hour a month. Now how much kilograms of palm oil shell is this? The constanta is 1 kilograms of palm oil shell is equal to 4 kilocalories, and 1 joule is 4,180 calories. So we need to convert our need into joules and then to calories. Let's go back to our need, which is 75,000 kilowatt hour a month. To convert it into kilojoules, we can multiply this with 3,600, which is 1 hour is 3,600 seconds. Now, after the multiplication, we have 64,593 kilocalories. Remember, 1 kilograms of palm oil shell is equal to 4 kilocalories. So, how much kilograms we need? It is 64,593 divided by 4, which is 16,148 kilograms. Now, the shell price is 500 rupiah a kilograms. So the cost we need to spend on energy is 16,148 multiply 500 rupiah, which is 807 for 163 rupiah. Alright, next is water. It is not as complicated as energy calculation. We need 4-fold of water for every kilograms of EFB. So, here, the raw material is 6,000 kilograms of EFB. Days is 25. 6,000 kilograms is equal to 18 cubics of water. The need is 4 times of EFB equal volume, so it is 18 multiplied by 4, which is 72 cubics a day. To find how much water we need for a month, then 72 cubics multiplied by 25 days, which is 1,800 cubics. The price for 1 cubic of water is 1,500 rupiah. So, the cost we need to spend is 1,800 multiplied by 1,500, which is 2,700,000 rupiah. Now, is manpower. We need 10 persons to operate our factory. The wage will be 8 million rupiah each. And the next is depreciation of investment. It is common, so let's skip this as well. So, the total number for all expenses is this. Alright, now we're talking about income. Basically, we have 4 kinds of products here. Palm oil is the product of preparation lane, lignin, bioethanol, and fertilizer as the products of their respective lanes. We have something to be explained here, especially in the quantity column. Assume that our daily capacity is 6 tons of FFB, full fruit bunches. Take a look here at the palm acid oil's quantity. You may wonder where this number comes from. Now take a look at the formula editor. 0.5% is a palm acid oil contained in 1 kilogram FFB. Empty fruit bunches, 100. Divided by 23 represents the percentage of EFB in the FFB, which is 20%. 6,000 is 6,000 kilograms, which is equal to 6 tons. Now, about the days column. 25 days are the days used to work each month. Now, about the quantity of lignin. We have 20% of lignin in every kilogram, so the formula is like so. Next is bioethanol. We have 20% lignin in every kilogram, so the formula is the same as of lignin formula. Next is fertilizers quantity. Let me explain this formula. 60% is everything left after the earlier process, which is palm oil acid on the preparation lane, delignification, and bioethanol extraction. 6,000 is the quantity of the raw material. And 180 is an additive material, which is phosphate. As much as 180 kilograms of phosphate is added to make fertilizers. Fertilizer is a popular commodity and is highly searched for, while bioethanol is taking its role in supporting the government in the E5 Energy Self-Sufficient Program. Derivation products from lignins such as toluene, benzena, and xylena will be of help to reduce import volume in the petrochemical industries. There are always risks in everything, especially in the business world. The fluctuation of the selling price will make our income unstable, but with high selling margin, we believe we can overcome this. The fluctuation of an additive material will also affect us. Other than that, we use many overseas technology, which is risky in case of an embargo. We can reduce environmental pollution by processing EFB using our way. The chance of EFB being burned is significantly reduced. Indirectly, we are reducing carbon emissions by maximizing the availability of an organic fertilizer. Indirectly, we are supporting the usage of organic fertilizer. Soil pollution and water pollution are also reduced indirectly, as the availability of EFB is also being reduced by our existence.